Hello everyone, welcome to my channel. Today we are building a diabetic predictor using Python and machine learning, and we will load the real world data, train the model and make the predictions. And this video would be perfect for the beginners and the experienced guys as well. Those are working in deep learning and machine learning models. So let's see how we can implement and deploy such models. So for creation of this model, we would have the real world data with me in CSV file, and then uh, what we would do here is extracting the features. So features, look at here, these are actually independent variables. Okay, so those are pregnancies, glucose, blood pressure, BMI and age. These are our independent variables, and our dependent variables would be one that is nothing but your outcome. So it would have only the patient is diabetic or non-diabetic patients. For creation of the model, that we would use random forest classifier, and for the implementation of this model, we would use the library like scikit-learn libraries and the pandas libraries. And for deployment purpose, we use the fast API. So let's go to how we can do this. So for model creation, we have to do some data collection, and then we do some pre-processing part. After this, the model selection, in our case we have a random forest classifier, and we will do some we will train the model actually, so based on our random forest classifier, and then we do some evaluation of the model, the performance of the model, actually how it works. And then for the model deployment, we would use you know deployment of trained model, and for doing this we have to do some API integration, and then we would check some monitoring, and then if model performance is not good, then we can um, tune the model again, and then we can redeploy the model. So this is how we would do here, right? So let's go to our VS Code setup. So in VS Code setup, we have I have installed actually a VS Code. So here also we can write our Python program. Otherwise, there are a lot of tools available in the market. You can use Anaconda, you can use Google Colab, and yeah, in my case I have used VS Code. So later on we can see in other tools as well. So here is the directory structure. So let's explain our directory structure also, that is very important. So we have a model ML diabetic predictor project I have created. Within this we have config directory, then we have a data. So raw data, I have kept these diabetic.csv file here. Okay, so if you look at this data, let's analyze it. So pregnancy, glucose, blood pressure, and then we have this BMI, and then we have age, and last we have outcome also. So if you look at the outcome, it has 0 and 1. So 0 means that patient is diabetic, and 0 means sorry, for 1 it's a diabetic, 0 is for non-diabetic. Okay, so this is our data, and then here it is model and train models. So this is for the notebooks, but in our case we have a .py file. So we would create the model within the source directory here itself. So we don't have it right now. We create one Python file here first. So let's say train.py. I have created one Python file here. So let's go to one by one how we can write this program from beginning. Okay, so for we have to import some libraries to write the model. So first of all, we would import pandas. So the use of pandas, why we should use this panda? It's a data manipulation a library in Python. Okay, so we will use alias as PD. Okay, and then go for from scikit-learn libraries sklearn dot model selection. And why we should use this library? So scikit-learn libraries is where you can have train and test data a split function, so that you can import that data that what is called train and test split. Okay, so I have imported here, and then from sklearn dot ansible, and from ansible is actually used in case of because random forest classifier algorithm, it's available in within the ansible, right? So we have to import the random forest classifier, and after this we will use one more important library, that is nothing but your joblib. So joblib is used for your when you try to save the model, okay, or save the model which you have created it. So for saving the model you can use joblib library. Okay, so we can use later on also, later on actually, not once the model gets created, then this library gets used. Okay, so now maybe what we can do here is, next is we have to load our data. Okay, so data is available here in our data. Okay, so yeah, data is available in data and then raw, and then okay, so we have to import this data. So what we should do here is data frame, and then is equal to pd dot what is called we have to read this csv file. So read underscore csv. Okay, read csv, and then what is the path here? So our path is c colon, yeah, then we have, okay, better, okay, 1 second, pwd have this, yeah, copy this, and then so I have copied this. So yeah, then within the model we have src model predictor, we have data, and then we have raw. After that we have the file called diabetics.csv file. We have kept it here. Okay, so we have kept this file and put in within the double quotes, you have to kept it. Yeah, it is there. So Till this step we have read the CSV file. Okay, and let's say if you have read the CSV file, then probably for checking purpose we can do this. For example, let's say what how many columns are there, we can check like this. Columns, what are those columns, right? So what we can do here is comma and then df dot, so df is nothing but your data frames, columns um columns dot, you can use what is called to list, uh, to list, it's there, okay, yeah. So if we use to list, yeah, to list is a function, so better we have here something like this. So now if we try to run this program, so yeah, it's from job lib. What is the problem here? Job lib, okay. Sorry, it's not actually from, it's import job lib, right? This is my bad. And then we try to execute this Python program. So what is this? What is this? From job lib is clear, right? Clear, and then okay, so try to run this. Yeah, so let me solve this problem first. So probably the problem is I think this is not getting interpreted, so let me change to this. Yeah, double slash, okay, this might work. Again, this is giving a problem. So we have the problem here, so I have corrected this. We have to use double quotes, double slash here. Now if you look at this, yeah, this is our number of columns which is present in our data set. Now let's say if I wanted to get some uh, data, let's say for example print, then I wanted to print some sample data which is there in our data frame. So what we would do here is, for example, I wanted to print some 10 records, okay, from my data set. So you can use something like this df, and then you can give how many rows you want to be printed. So by sequentially it is give you the 10 records, okay. And now if you want to print some random records, so what you would do here is um, df dot sample, and then you can pass for example 10, right? So this will print your what is called 10 records randomly, it will print. Yeah, if you look at this data, so these are the random records, random rows, random 10 rows would be printed. So this is how you can use these print to check your the data set which is got loaded, right? And now we have to prepare some data, right? So what we have done till now, we have done two steps. We have loaded imported our libraries, imported the libraries which we need it, okay, for manipulation and saving the model. Okay, this is step number one, and this is step number is loading the dataset. So loading the dataset also we have done. Now what we are going to do here is uh, preparing the dataset, preparing the data. So in for the preparation of the data, what we would do, if you look at, we have train and test split function we have imported from sklearn library from the model selection. Now, so coming to X, so X is nothing but I told you, right? So this is nothing but independent. Your what is called X is nothing but your independent variable. So let's write it down here. X would be your independent variable. X is equal to INDEP, independent variable, and Y would be dependent variable. Okay, so for if your X is your independent variable, then we have to extract the data. We have to extract the data from the given data set. So for extracting this X, what we should do, we have to extract from the data frame. So df, and then what are those columns? So column is nothing but your pregnancy. So I kept it pregnancy, and then we have another column called, let's say, glucose. So we have glucose, and then we have another data called your blood pressure. Okay. So blood pressure is another your independent variable, and then your another is BMI. Okay, so I kept it a space wrongly, comma, then I have to give age. So age is nothing but something like this. Yeah, so now our X is ready. Okay, so we have extracted X from our data frame. So your independent variables, independent from the independent variable, we have taken X. Now taken Y. Y is equal to nothing but your outcome. So df, and then we take outcome. So outcome. So for outcome also we have extracted. So X and Y are ready, right? Now if your X and Y are ready, then we have to split the data. So now how we can do splitting of the data? Splitting of the data into test and train set. Okay, so how we would do splitting of the data? We can okay, take something like this: x train comma x test. So this sequence is very important. So always this sequence would remain same, so make a note of it. Then we have train x test, x train y, x train x test, y train and y test. Okay, so we got this data, and then we have to use train test split, and then we have to pass here our x comma y, and then we have to pass the how much test size we want. In our case, we need 20% data for our test set, and then the random size would be random state would we will keep at let's say 42. So here we have splitted our data, your independent variable and your what is called a dependent variable in x train, x test, y train, and y test. Okay, now we have to train our model. So we have to train our model. So for training the model, what we would do here is model, and then for training the model we have chosen a random forest classifier. So yeah, we would take a random forest classifier in a variable, and then we need to use model.fit, 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 and there we have to pass x train, x train comma y train, x train comma y train. We passed it. Okay. So your model is also got trained, and now we have to save our model. Saving the model. Okay. Saving the model. So how to save this? We have to use joblib library. So joblib library, and then we have used dump function to dump the model, comma. Okay, so yeah, very important. For saving the machine learning model, we can have .pkl file or h55. So in first we will learn about the pkl file, and then we'll see later on h5. So we would give this file name of our model as, let's say, diabetes, diabetics, and then underscore model, and then let's say I've given pkl file. Okay, so your model is model file name is pkl file. Okay, and now when you dump the model, your model gets saved. So what we give here, model saved as pkl file. Okay, so our model got saved, but we wanted to save our model, train model, in this location. Okay, so better we use this path to, okay, so here copy, then we will pass here, okay, model, predictor model, and then okay, yeah, then we have model, and after this one more is trained model, trained, trained underscore model, and then we have the file name. Okay, so this, your model gets saved with this file, pkl file. Now save this file, python file, and then we try to compile our train.python file. So some problem came, and then we have to solve this. What is that? No such file or directory present. Okay, so this location seems to be not correct. So models, okay, it is models, MODLS. It's not model, it is models. Okay, so let's try to rerun. Okay, no such file. Mhm. No such file. So machine learning, then ML model, predictive model, models, train model, and then diabetes.pkl file. Okay, yeah, we did dump also. So why it is giving problem? Random class forest classifier. Okay, so I have corrected the problem. So here this folder name was not correct. It's models actually. This is typo error. And now if we try to run this program, you will see, yeah, now you can see this model saved as pkl file. Okay, now look at this file also in this location, models, and then you can see diabetes model.pkl file got saved here. Okay, so this model you have to use this joblib library to save your model at the destination wherever you want. In our case, I have kept it in our models under the training model. Yeah, dataset training model library. Sorry, directory. Right. So this is how you can create your model and save your model as PKL file. So now we need to check for how we can deploy this PKL file. Okay. So for doing this, we have to write one more Python file. So for writing this Python file, okay, so where we would need this here, we have src data features and models. So within the model, we have this train dot Python file, and now for running this for deployment purpose of this file, this model, we would create one more file. Let's say it's called main dot python file. So I have created another file. Okay, so now we need to write one main.python file for the deployment of our the model which we have created with the help of train.python file. So okay, so here also um, we would write we would import some libraries first of all. So from for example, yeah, from we would import fast API, fast API, and then import fast API again from IDA antipantic, and then import for the base model. We have to import base model, import base model, and then again we have to import joblib because we have to load the model here, and then import numpy and numpy as np as alias. Okay, so what we would do here is app and then fast API, sorry, fast API, and then fast API. Now we have to load our what is called the pkl file which we have okay created in my previous step. So let's do one thing. We have to import OS. So yeah, OS, and then what we do, model path. So model path where sample path where this is our model path, copy and then paste it here. Okay, so after this, if for example, if not OS, we have to check the path. If it is a path dot exist, if it is exist model path, then fine. If it is exist the model path, then fine. So print okay, so we have to print model del model path model file, actually file not exist, file not found, file not found. At what we can do here is model path. We can provide model path. So yeah, we can write something like this: model and model underscore path. Okay, so model path, and yeah, it should work. Okay, else what we have to write here is else model is equal to joblib dot load. What we have to load, model path. Should have credit. So yeah, save it. Let's see, try to run this first, check this path is there or not. So we have to clear this first of all. So one second. So we're trying to run this okay, whole stuff. So y means that file path is model path is present. Okay, yeah. So now we have to use this path is okay. We have created a fast API instance, and now we have to write a class, and then we have, okay, this is a fast API where we have to provide a input and then output. So, output we would expect. So for giving the output, we have to create a class. So we would create something like this: BETES diabetics input. So we have a four what is called independent variables. Okay, 4 or 5, yeah, 5 independent variables. So we have to use our class to provide the input. So I have created a base model here, pass the base model here. So what is our main dot, this is train over. So in this train, what are those parameters? Yeah, pregnancies. So here pregnancies colon, I have taken int. Okay, and now sorry, it's not semicolon, it's colon actually. It is not, yeah, it's int. And then we have called glucose also. So better copy and paste. So glucose, it's float, FLAT float. And then we have which is called blood pressure, BMI, age. So blood pressure is blood pressure, yeah, it should be actually float. So float. And then BMI, BM, sorry, BMI. Then it should be also a float variable. And then now we have age. Age is also it should be in age in terms of integer. Yeah. So we have created our class for inputs. Now we have to write our APIs. So in first API app dot get, we have to pass a root. Okay, so here it is root. And for this we have to write definition. Definition, we have to read, for example, read root. Okay, so yeah, read root colon. And then we have to return, return, for example, in case of return we would write a message. Okay, so a b e t statistic predictor, PREDCT prediction model is uh, ready to predict, PREDS predict the um, output. Yeah, so now we have to write another operation is called app. We have to give the input, and then based on this we get the prediction as part of our outcome. So we would pass here the predict, um, uh, we have given the context as a predict. So now we have to write the definition. So if we write definition, so predict function, and then within the predict function data, we have data. And for input we have a class, right? So we have to pass the class here and then put semicolon. And now input data, yeah, input data array we have. So here input data, now we would say we have taken here numpy. Okay, numpy dot, so here we will pass as an array. Okay, so array. And then in this numpy array, so we have to pass the data dot predict pregnancies. Yeah, data dot pregnancies. Then data dot your second input would be glucose. And now data dot this would be blood pressure, I guess. Yeah, blood pressure. So data dot yeah, data dot blood pressure, sorry, data dot blood pressure. Okay, and now abhi data dot BMI, comma data dot age. Yeah, so we have given our inputs here. Yeah, inputs are ready. Okay, so if inputs are ready, then we have to take a prediction, PREDICT, and prediction. prediction, then model object. After this we are using a predict function and input, yeah, input data, yeah, input underscore data, and we have to pass our array's first element, and then hold on, this input array, and then how to pass it here, something like this, 0. Okay, then return diabetic, okay, return is something we have to write like this, is diabetic, diabetic prediction, prediction, diabetic prediction. So diabetic prediction is would be in terms of boolean value, either it is yes or no. So we will pass our prediction, yeah. So we have passed the prediction here. So bool, here we have done some mistakes, I think. One second, here it is, yeah. So something like this. Now our input is ready, okay, and then prediction model dot predict input 0. Okay, so let's try to run this program first of all. Yeah. So let's see. Okay, so now you look at this, our this deployment model is deployment program is main.py. So you can run this program from here also via console as well. So yeah, Python 3, I have installed Python 3, so okay, good. So it's running, and now we need to create a server. Okay, so for this we have a unicorn uh, server, right? So for what it does here, it will give you it will give you a running server for unicorn to test your fast API. So how we can use this? So unicorn, if it is not there in it not installed in your machine, so I will provide the commands to install the unicorn. So here you can write something like this: unicorn main colon app. So then what is called reload, reload, okay, reload. So yeah, and no, one actually, this one more problem is there. This code is one bracket. I missed it here. Just two brackets actually. Yeah. So this is okay now. So reload. So you can use this unicorn. Okay. Character is not allowed. What is that? So what is that? This is the problematic part. W bracket I have taken it. So what is the problem here? So what age? So this bracket and then two brackets. Date, call, age. Okay. Let's see if it is. So age. Okay. And now, oh, fine. So this prediction, now we need to run this server, unicorn server. Okay, so for running the unicorn, okay, so here, so uni, okay, we have to write prediction python th python 3, python 3 actually, python and then minus m. So uv corn and then main colon app, then you called reload. So python, it's python, python, no such option are why is it? Oh, okay. I think I did it wrong. It should be something like this. Okay. So now we'll try to run unicorn python python minus m uv corn main colon app, and then we have to use reload and reload. Okay, so once you're done with this, and you have to execute this command right here where you have a main dot python file, because it looks for your main.python file, right? Yeah, so here if you see it, right, application server is running, it started running on host is 127.0.0.1.8,000. Okay, so now we look at this. So I'll use browser, then yeah, so if you look at this, your diabetic prediction model is ready for predict the output, right? So what we would do next here is docs. So now if you look at this your two APIs we have created it, one is get API, another is post API. So get API, it gives the first one that we saw it already output, the model is ready to provide the output. For prediction we have to do this, we have to use this predict API. So now we can try this out. So if we try to look at this, we have pregnancies, glucose, blood pressure, BMI. Okay, so this is the same thing where we have the input here, we have passed as a class, right? So we are taking as a first element of the array, so we have to provide all these inputs. Now we look at the data first. So if we look the data, we have where is the data? So for example, our data is within the row itself. So we take an example of the first one. Okay, so yeah, so our first example is this one, right? So pregnancy is glucose, it's a 6 for 148 now. So we pass 6, and then glucose is 148, and then we can check for this one glucose, and after this glucose by 72. Okay, so blood pressure is 72. Now we have to check the age and BMI. So BMI is how much? Blood pressure, this is your sick thickness, 0 insulin, and then 33 and 50. Okay, so we have to pass 33 and 50. Okay, so these inputs we have provided. Now we have to execute. Okay, so we got some internal server error. To check this first. So now we need to solve this problem what we have faced in as part of the internal server error. Okay, so let's see what is the problem here. Input data. Okay, so we did some mistake here. This is nothing but input. Okay, it's a typo mistake. So I have corrected input. Okay, now we need to save this, and then I have to re-execute this. Okay, and meanwhile I need to close the server also. Okay. I have closed this server, and now so executed this again, run this program, Python program. Yeah. After this we have to restart the server again. So once the server is ready, so what we would do here is we have to copy this input first. I copied this input, and then our API is ready once again. Let's see. So predict post, then we need to try this out. So inputs are there. Okay, so we'll try to execute this. Okay, again we saw some problem. Okay, got the ID instead of value expected 2D array. Okay, 2D array. Yeah, there was a problem in 2D array, so this was I have actually provided first. So this should be actually in 2D form. Okay, now so once this is done, shutting down, and then it has restarted again. So let's see if it works. Yeah, now look at this. The prediction is diabetic prediction is true. Okay, for this input. Now we can test one more use case. We can check for the false one. So 185 and 66. 185 and 66. So this is 185 and we have 66. 66. Two more BMI and your age. Yeah. So BMI 66. BMI would be 26 and age is 31. 26, 31. So 26 and this age is 31. Okay, so let's execute this as well. So we got false, right? Now if you look at this prediction of this data is correct, right? So for first case we saw it true, and for second case we saw it 0. So this is how you can do this, test your API via test your model via fast API. And similarly, you can check all these predictions via curl command as well. Yeah, so this is your curl command. This is also you can test it thoroughly, right? So this is how we can create the model, implement the model, train the model, and then deployment of your model by using fast API. So that's it for today. We will see something in my upcoming videos uh, based on the machine learning models and the TensorFlow as well. We will cover it. Okay. So thank you very much.